So I'm going to backtrack just a little bit to 6.1 because we didn't quite finish yesterday. So let me just backtrack just a little bit. I don't think we did this. Let me find a polygon. And let's see, that's 6 sides. Does it really matter which one I do? Let's do 8. Now, we did that, didn't we? We talked about the stop sign, right? Measuring the stop sign. Yeah, so we did that, so I don't need to do that part. All right, so let's do something else. I just remembered that we did that yesterday. All right, here's another one. What I'm going to do is I'm going to make a, whoops, I didn't want that. I want this. There we go. I'm going to make a quadrilateral. It's not any like special kind of quadrilateral. It's just basic any four-sided figure. I'm just going to make it like this. Yep, and it's just going to be a quadrilateral. But I'm going to show you one more thing. We talked yesterday about what the sum of the interior angles are. So what do you think I'm going to do now?
So the exterior.
Very good. I'm going to find the sum of the exterior angles. Okay? And what do I mean by the exterior angles? I don't even see any exterior angles. It looks like everything's inside of this, doesn't it? Okay? But what I'm going to do is this. I'm going to take one of the sides. I'm going to take each side and extend one of those in one direction, I should say. All right? So watch. I'm going to take that and extend that. Everybody with me so far? Then I'm going to take this one and extend that. Oops, it's not what I wanted. Let's grab it right there. There we go. Extend that one. I'm going to extend this one. Now, why am I extending these? So that I have what kind of an angles? So that I have exterior angles. Because we're going to find the sum of the exterior angles. And I thought I was going to do a little proof for this, but I guess I'm not. I'm just going to tell, since we're just since we're just finishing up the last lesson, guys. Since we're just finishing up the last lesson, I'll just tell you what it is. So, the sum of the exterior angles of a convex polygon, okay? I'll just say, you can throw that in there if you want. I'm not going to write it down. But the sum of the exterior angles of any polygon or any convex polygon is always equal. And this is interesting. When it was an interior, they could change, right? Depending on how many sides. Remember that? How many sides? We took 2 away from how many sides to get how many triangles. Then we multiplied by 180, right? Because that's how many triangles were inside of it. But the sum of the exterior angles is way easier. It's always equal to the same exact number, okay? And that number is something you should recognize, and it's 360 degrees. So if this is angle 1, this is angle 2, this is angle 3, this is angle 4, what do angles 1, 2, 3, and 4 add up to be? 360 degrees, exactly right. Everybody with me on that? It's pretty easy, isn't it? Yeah. Now, there is a proof to it. I'm not going to go through it just because this was last section. I want to get on to this new section. But just believe me, it's true. Okay? I hate to say that. It's terrible for a geometry teacher to say, just believe me. We usually prove stuff all the time. But in this case, we're going to do that. So what if I gave you this? Here's a possible question they could give you. Let's change colors to yellow. You see that a little bit better? What's that? Oh, I get them from homework problems, and I don't usually make them up myself. I'm not that good. Now, this is a quadrilateral. So in a quadrilateral, the sum of the interior angles is going to equal what? The sum of the exterior. Because on a quadrilateral, all the angles add up to 360, right? But that's the only time. That's the only time that happens. If I had a 5-sided figure, right, and I extended all the sides, the outside angles would still add up to 360 degrees. Does that make sense? Okay. Right here, what did I give you? I just gave you the interior angles, right? Anybody have a calculator on them? Get your calculator out. Punch these numbers in. These hopefully should add up to 360 degrees. Do it real quick. 115 plus 105 plus 67 plus 73. 360. Okay, good. So we know that's true. So let's do this. Keep your calculator out. How do I find, let's do this in a different color. How do I find this angle right there?
Minus 180 from.
That's right, because it makes a straight line, doesn't it? All right, so these are supplementary. So do the math for me. What's 180 minus 115?
75.
Okay. 65, isn't it? Where's your calculator? That's why I want you to use your calculator. Make sure we get this right. So that's 65 degrees. Okay, what about this?
75.
Yeah, we should be able to do that one in our head. That's 75. You see what we're doing? Because it makes a straight line, we just take it away from 180. So we take this away from 180. What's that? 13? How about 13? 113. And what's this? 180, it'd be 107. Okay? Now, do me a favor. I want you to add up all those blue ones. 65 plus 75 plus 113 plus 107. That's 360. How about that? Now, we could do that with any polygon. All right? If I know all the angles inside the polygon, I could extend the sides of that polygon and do the supplementary thing, and you're going to find out all of those are going to add up to 360 degrees. I'm not going to do this, but maybe you can visualize this. I'm not really going to draw it because it's just going to take way too long. It'll take almost the whole time just to talk about it. And I got a new lesson I got to teach today. But what if you had, I tell you, I can do this though. Maybe you can visualize it. Oops. Why did I do that? Boom. There we go. So this one's going to be 6 sides. So watch. So there's 6 sides. Okay, watch. If I extend it, boom, 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 all those sides, what do all 6 of those exterior angles add up to be? 360. Okay. What if I did this? What if I made this like, we'll do a big jump. We'll do 10 sides. So look at this. Let's scoot this down a little bit. Okay. Now watch. If I extend all the exterior angles, what do they all add up to? 360 degrees. Okay. I want you to tell me what this thing is starting to look like the more sides that it has. So I'm going to go from 10 to 20 now. Let's do 20 sides, see what that looks like. It's starting to look like a circle. I mean, they're straight edges. Do you see that? They are straight edges, but it's starting to look like a circle. So do you see, I want you to see the relationship. If I had 1,000, let's just see, I don't even know if this program will do it. Let's just try it. It probably won't. Pretty much 1,000. Let's see if it does it. And then boom. Oops. Yeah, but it makes that stupid circle, but let's do this. Let's try it again. There we go. Okay. There's 1,000 sides. What's it starting to look like?
It's so straight.
Can you see? I don't know. I think they're all kind of blended together. All right, let me try to zoom in. Yeah, you kind of see it a little bit. You see how you got these little dots right there? Okay, oops. There it goes. Anyway, you kind of see it, right? So obviously, what's it do? It starts approaching a what? A circle. Whoops. So how many degrees are in a circle? 360 degrees. Do you see that? So what are all the exterior angles to this 1,000-sided polygon? 360. And it starts, the more and more sides you get, the more and more it starts looking like a circle. So do you see the relationship between the exterior angles of a polygon and the total degrees of a circle? 360 degrees, isn't it? Okay, we actually have a whole entire chapter just on circles. So that's exciting. There's a lot, believe me, a lot about circles. All right, let me get rid of all this junk. And then we can start on the actual new stuff. All right. Okay, and let's get rid of this mess. Oops. Right here. Start with a clean slate. There we go. All right, now we're ready to start. All that just to finish up yesterday's lesson. Okay, enough of that. Let's take a look at this. So let's make a parallelogram. So I can use this program to make a parallelogram. You say, well, that's not a parallelogram. What is that? But it is a parallelogram. You're right, Zion. Okay, it's a parallelogram because both pairs of opposite sides are parallel to each other. That's the definition. It is quadrilateral. It's also a rectangle, probably, right? It's not a square. Let's see. All the sides have to be equal. That's right. Okay. This is what a parallelogram in geometry, usually we make it look like this, okay? It doesn't have to be. It could look like a rectangle. It could be a square. Agreed? And it could be a rhombus. But this is what we normally look at and say, oh, that's a parallelogram, okay? Now, what's the definition of a parallelogram says that both pairs of opposite sides have to be what to each other? Parallel to each other, okay? All right? And we have a way to write a symbol. You know how we write triangle ABC? What do we make it look like a little triangle? Agreed? All right, we make line segment AB. We put a little line segment over top of it. What do you think the shape, the symbol for a parallelogram is going to be? By the way, let's name this ABCD. Yeah, we just draw a little tiny parallelogram like this. Okay? That's the symbol for parallelogram. Everybody got it? Doesn't matter how this thing is angled up or down or if it's leaning to the right or leaning to the left. We always make our little parallelogram symbol look like this. Now, here's how we read the thing. You know, on a triangle, it doesn't matter where you start or which direction you go, right? If you had a triangle ABC. On this one, it doesn't matter where you start, but it kind of matters what order your points are going to be in. What do you think?
I always look at that as the quadrilateral symbol because I noticed that you could also, I think it's used in rectangles and squares.
But we don't really have a symbol for a quadrilateral because a quadrilateral could look like all kinds of stuff. But parallelogram's a little more specific. So we see how this slants a little bit like that. So this is what our symbol is specifically for a parallelogram. We don't really have. If you wanted to name a quadrilateral, you would actually just write the word quad and then call it ABCD or whatever. Okay? Now look at this. When I call this a parallelogram, I don't have to start at A just because A is the first letter. Okay, I don't have to. I could start at D, at B, at C. It doesn't matter. Okay, let's just start at A though, just to make it easy. So if I start at A, I could go this way or I could go this way. I cannot do what? A, C. All right, everybody with me? You got to go in consecutive order. Kind of like, but a triangle, it doesn't matter, right? Because there's only three. So it doesn't matter what order you go in a triangle. On this one, it kind of does. But again, it doesn't matter where you start. You could start at A if you wanted to, but I could call it ABCD, right? A, B, C, D. Or I could call it, if I started at A, only one other way. What could I call it? A, D, C, B. Okay, I'll put or. Parallelogram A, D, C, B. I cannot do this. I cannot say A, D, B, C. You got it? You can't skip across the middle like this. You got to go around the horn, as we say. All right? So A, D, C, B, A, B, C, D. Or you could, if you wanted to, I'm not going to write all these down, but if you wanted to start at B, that's perfectly fine. You could. You could call it what? B, C, D, A, or you could call it B, A, D, C. You got it? So there's a bunch of ways. It looks like there's, 8 different ways you could probably name this thing, right? Start at 4 of these points, go one way, go the other way. So there's 8 different ways you could name this thing. But you cannot name it AC, BD, or anything like that. You got to go in consecutive order. We good with that? All right, that was easy. Got that out of the way. Now we're going to do some real stuff. Okay? All right, let's, I'll tell you what. I'm going to just copy this and paste it. What we're going to do, I could just tell you what these theorems are and And you would be, if I could grab the dumb thing. Come on. There it is. That's not as easy as it seems. All right. So I could just show you something else that's true about a parallelogram, a couple theorems. But what I want to do is I want to show you why this is true. And that's why this lesson is going to take a while. I probably won't even get halfway through this lesson today. But hopefully I'll get through at least this first part. So what I want to do, I'll tell you what. I'll cheat a little bit and tell you what we're trying to show that's true. We already know that this is a parallelogram, all right? And I'm just going to name it what I named it in my notes. So I started A down here this time, and then this is B, this is C, and this is D, all right? Now, we know it's a parallelogram, so just by definition, I know that those two sides are equal to each other if I told you. So what they'll do, they'll say, I don't know, sometimes they'll use the word given, all right? That this is, what does that symbol right there mean?
Parallelogram.
It means it's a parallelogram, all right? So I could call it A, B, C, D. So if I give you that this is a parallelogram, if they say this is a parallelogram, we know for a fact that B, C, and AD are parallel to each other, agreed? Because of the definition of a parallelogram, because the opposite sides are parallel. We also know by definition what? That AB and DC. Let's go in the right order. Let's go, if I go A to B, then I would go what? DC. So AB and DC would be parallel to each other. So I know those by definition. Now, there is a theorem that we're going to learn here in a little bit that says that the opposite sides are not just parallel, but what's your gut instinct on the length of BC and AD? They are equal, okay? And they absolutely are. On a parallelogram, the opposite sides are equal. And I could just sit here and just tell you that and then move on, but I would feel guilty because I want you to see why. Okay, we can show why, just by knowing that these are parallel to each other, I can show why that this side and this side are equal to each other. Okay? Correct. Trapezoid only has one pair of parallel sides. A parallelogram has both pairs of parallel sides. Okay? So we also know that, I'll tell you what, I'll do this in a different color. Let's do it in blue. So what can I mark here? The theorem says that this side and this side are equal. And what else does it say? That the opposite sides are also equal. Okay, the other two sides are equal. That's the theorem, all right? And you're like, well, why is that true? Well, I'm glad you asked, because that's what we have to do. And that's what we do in geometry a lot, okay? We say, well, why is that true then? Let's prove it, all right? So I'm going to get rid of those equals right now. So now let's work under the assumption that we don't know they're equal. Let's try to prove that they're actually equal to each other, all right? So what I'm going to do is I'm going to do this. And you're like, well, how would I know how to do this? Well, because it works. That's about the only thing I could tell you. So I'm going to just draw a little diagonal here, okay? Now, what do I have? I got two what? Two triangles, okay? Now, I know stuff about parallel lines. Look at BC and AD. They're two parallel lines cut by a what? Transversal, right? So, well, not yet. Two lines cut by transversal. I'll tell you what. Sometimes I have to visualize it because when you got all that stuff combined, it's kind of hard to see it. So there's my BC and AD, right? And there's my transversal. So I got some angles that are equal to each other, don't I? I've got this one and this one are equal to each other, correct? So which ones are they on this? It would be C what? A, D. Would you agree? That one and that one's the same. And then what else? What is it? CAB? No, that's not equal to each other. This one right here, what's this angle right here? It's that top parallel line, it's that transversal. It's on the left of it. B, C, A. All right. Everybody see that? That this angle right here is that angle right there. So I know those two angles are equal just because those lines are parallel. Everybody with me? Okay, now AB and DC are parallel to each other. There's AB, there's DC, and then you've got this line going through here. What else is equal to each other? Well, this one would equal this one. So where is that here? That's this one, BAC, very good. And then it would be this one right here, which would be DCA. Good. Right there. You with me? These two right here are parallel because they're alternate interior angles, right? Well, this one and this one, they're alternate interior angles as well because parallel lines, right? This line and this line are parallel. This is a transversal. This one and this one are alternate interior angles. Now, does it start to look familiar to something that we've done in the past? Yeah. I've got two triangles. I've got an angle and an angle and an angle and an angle here. What else do I have that might be equal? What side? Give me letters. In letters. Name it. AB? No. AC. Right, look. AC. I'm going to put, I tell you what, I'm going to put 3 arcs there. Is that all right? Because I'm going to use 1 and 2 for the other ones. All right? What do you think is true about these two triangles? Not equal. What do we say? Congruent. They're congruent. Why are they congruent? No, it's not side. I don't have 2 sides. I only have the one side. It's angle, side, angle. Do you see it? So look, I got an angle, a side, and an angle here. And I got this angle, this side, and this angle here. They're congruent to each other. So I could say, let's put this in a different color. Now watch, we're getting somewhere with this. I know the bell's going to ring in like 2 minutes, but watch. Triangle. Let's name this triangle up here at the top right here. What would you name it? A what? ABC. Good. And that would be congruent to this triangle. Now, if I go ABC, I'm going from 2 arcs to no arcs to 1 arc. What would it be over here? 2 to none to 1. 2 to none to 1. So it would be CDA. Everybody see that? Yeah. That's why it's important to be able to put these in the right order. We had a test on that not too long ago. Now, what were we trying to do in the first place? We were trying to show that AB and CD are equal to each other. Agreed? Do we have that over here? Look at AB. AB and CD are in the same spot, aren't they? So that means that AB has got to equal CD. Everybody see that? Because they're congruent to each other. This part right here is exactly the same spot as this side right here. So AB and CD are now congruent to each other because we showed that the triangles were congruent. So I can put a little arc right there. I'll tell you what, I'll put 2 arcs there since this has 2 arrows. Don't pack up. So those two are equal to each other. All right? What else are equal to each other? What about BC? What's equal to BC over here? Okay, let's go in order. BC and DA. So that means, that means that BC has got to equal DA. BC is right here. DA is right here. Look what we did. We just proved, okay, just by knowing that those sides were parallel to each other, we just proved that the opposite sides now are actually equal to each other, which I think is kind of cool, all right? So you don't have to just believe me by saying the opposite sides of a parallelogram are equal. Now you can prove it to somebody. So if you're in the hallway talking at the locker and you happen to tell somebody that the opposite sides of a parallelogram are equal, your friends will probably say, I don't believe it. Prove it to me. And now you can do it. All right? I'm not going to give you any homework tonight. We didn't get far enough. So we'll finish this up tomorrow and give you some homework tomorrow.
Have a nice night, Mr. Hammer.
You too.